the point is that in the low-code development, there are not only the people that can program, like the people that belong to Lero and Confirm, the Software Research Center, or the Center for Smart Manufacturing, where a lot of people actually can do coding relatively at low level, meaning assembly or Internet of Things or machinery code, etc., and some data analytics, okay? But it is full of people, like for instance, the people in the Health Research Institute, where the majority, the overwhelming majority, are people that have never written a line of code in their life, okay? And if you look at AI and if you look at digital twins and so on, for which also AI is used quite a lot in order to create actually models that can work as digital twins of something, at least for certain aspects, according to certain dimensions, okay? One of the big examples is the use of the same technology also to do digital twins of patients, or to create some kind of huge data analytics applications and so on. And it turns out that you have to work all the time with people who are application experts, but not coders, okay? So the low-code design environments basically have come out of that need of creating some kind of a bridge that is as good as code, in the sense that you can produce code out of those artifacts, but it doesn't look like code in the sense that it is not, let's say, a textual representation, maybe it is a graphical representation, and that the intuition that these non-specialists have about how these models work is, for whatever reason, right, okay? So the problem in that area is actually how to get representations that happen to match the natural interpretation intuition, okay, of these by these individuals who are parts of the teams in a lot of applications, so to say, but they are not coders themselves and they will never become codes, okay? So on the technical side, there are also people like Enda, for example, who is one of the PhD students in the CRT, Center of Research and Training in AI, okay? But also there, you're sitting in a lot of projects, like for instance, the assignment that you're going to have for the AdLib, which comes from a project that we have together with colleagues in the history department. It is a big digital humanities project, okay? And we are using various aspects of AI and ML in order to clean the data, which is the part that you are going to work on, okay? It's an exercise that we extracted actually using some of the, let's say, credible data, plausible data coming from that kind of data source, okay? But it could have been something completely different. It could have been catastrophe maps. It could have been insurance data or something like that, right? On which you're working, and you're working with people that are not coding, okay? So why is not working? Okay, so the way we were doing extreme model-driven design a couple of years ago was actually by using a number of tools that were distinct and, how could I say, disjoint from each other. So we had a very nice technology called Diva to model, for instance, the data part. And this was in the web, so it was really nice. And then there was, however, all the part that was modeling the logic of how an application works. And this had to be in JBC, which was actually a Java-based environment on top of Eclipse, okay? Where, however, the moment you wanted to change something in the data, you had actually to go back to the web application, then regenerate the data to Java, okay, import the services into the JBC, and now you could again do something, right? And then you could basically create your workflows like the DIME application, the DIME CR, so to say, that you have in JBC, and then you could re-export, so to say, the web application once it was completely generated and run it into the web environment of the Diva, okay? The problem is that it was a lot of back and forth, and it was a lot of different environments and very complicated to manage. So, new generation, a handful of years ago, basically we moved away from that way of doing things like Eclipse and a little bit of databases and a little bit of models, but on top of old style environments, and we moved actually to a different environment. So not only we moved to a different time, which is on the side, you know, left to right, the right is the new way of doing things, but we also added a completely new layer of models and ways of dealing with models about the kind of artifacts we are talking about, the kind of models we are talking about. So it's modeling the models, okay? So that with those kind of models as a language, we can then model applications, and then we can generate the code for applications, okay? So the environment that allows us to do all this magic at the upper layer, okay? So to create define new kinds of models, okay? Like the DIME models, they are defined in Cinco. The ADD models, they are defined in Cinco. And there are a gazillion of other applications, more or less industrial, more or less educational, more or less advanced, that we have already created, okay, with this environment. So that once you have defined in Cinco with specific languages, the specific characteristics of a model, like for instance, in the adlib, that you have the basic predicates and you can combine them as BDDs with these, different kinds of edges, and there are only two edges, and the dotted edges mean this, and the solid edges mean that, etc., etc. And there are some rules for when a model of this kind is well defined. Okay, for instance, if you have a Boolean decision diagrams, you can only have two values, 0 and 1, or true and false. So you cannot have a syntactically correct tree, okay, decision tree that has more than two outcomes, true and false, right? If you are working in a different algebra, you may have an infinite number of values, for instance, right? So depending on the algebra, depending on the kind of mathematical properties in reality that these models have, you have the one or the other language. And from the definition of this language, we also generate automatically the code for the editors. So while the JBC was hand-programmed in Java, and Diva was hand-programmed in another technology, okay, now our friends, DIME and the adlib, they are generated. So we defined in a language, which is a language that defines the models, how they look like, what are their syntactic and behavioral properties, okay? We define the models, then you push a button, and what comes is out of that is actually the DIME environment or the adlib environment, okay? So for DIME, we have given you already the compiled stuff. You don't see anymore that it is actually what we call a Cinco product. So DIME is produced by generation from Cinco, and it has a very rich category of models. We are not going to discuss all of that. You're also going to use only, in a certain sense, DIME CR, which is specifically created and fully instantiated already for this chain reaction game. So with DIME CR, you can only do that. There is a general DIME that is much more complicated and much more, let's say, industrially and professionally relevant, of course, but we don't have time in these 2 weeks to learn too much. So let's be happy to work with that one and just, get to know the principles, okay? But the adlib that you have got to know, so to say, in the complete generation starting from Cinco, because it is a much simpler tool, okay? The adlib is a brother, in a certain sense, of DIME and many other more, okay? So in our class, we are going to work only with those two. It would have been lovely actually to add something more, like for instance, new techniques that have to do with learning automata, learning the behavior of systems. So you have a system, you observe the system, and you actually create the model that is mimicking exactly the behavior of the system. So it is not a classifier of data, it is not just learning, let's say, something static, but it is really learning complex behaviors and sequences of behaviors, like what does a machine when it works, okay, or something like that. So there are technologies for this. They are also part of machine learning, like this Alex, okay, that Alexander Shivek, one of our moderators, has been designing years ago, okay. But this one is again, let's say, on the side of handmade in Java, okay. So it's not yet in the Cinco world, and so unfortunately, we don't have the time, so to say, to learn more and different kinds of models, so to say, with these technologies. Okay, so the question that you had was basically, okay, what is the connection between all these things? So DIME, the way it is created right now, okay, you take the DIME models, you generate them to JavaScript. and then they are deployed on the back side and front side, so to say, of a web application, and you see the effects, so to say, in the web application, right? For what concerns Dime, there is also another way of doing things, which is actually this one. You start with a Dime model. You want to end up with a JavaScript that runs in a standard runtime, okay? There is this new way, actually, of doing things, which uses heavily the Synco and the ADDlib, okay? So it turns out that when you start with a Dime model, you basically are using a specific, an application-specific, let's say, purpose-specific, special purpose, domain-specific language, which is a graphical DSL, specifically just for strategies of this game. So you're going to find a list of operations that you can do, okay? These are the SIBs. And so this basically defines a graphical DSL, the language that you can use Dime, okay, and you can basically do that, okay. How do you get it to JavaScript? Well, one of the possibilities is that you start with a model. So what we have up there in blue is basically the level of the Synco products, okay. These models, they have been defined, okay, by means of this specification, which is also a model, okay. It's basically like the language, the grammar, so to say, of the models, which is in Synco. Whatever is gray here is Synco. Okay, so once you have this is a specific purpose DSL, but there is also a general purpose DSL, which is what we call a simple while language. Okay, so if you have ever seen Java, Pascal, I don't know, Python, I mean, in every language, so to say, that we know, there is always a subset of the language, which is the very, very, very core. It is the one that allows you to do sequential composition, if then else, a couple of loops, which is basically the while, okay, and then possibly also hierarchy, which we can do, okay. So you can basically take this Dime model, which is application specific, and transform it into a general while language model, okay, which is also defined by means of a language, model language, which is this graphical while MGL, okay. And then inside the Synco, we have the ability of defining transformers from models to models. So how do we jump from one to the other? Well, we have also a meta grammar, okay, which is another grammar that basically defines the model-to-model transformers of the Dime to while, so that you can define a grammar for the transformation. You can generate code automatically from the transformation into this green element, which is code, which is the transformer, so that you have the model-to-model transformer, basically a compiler, okay, from your domain-specific model into a generic model that is equivalent. And you know that it is equivalent because you have the proof of this by means of the equivalence of the semantic definition of the model types. Okay, so this is important. This is the difference, for instance, between Synco-based DSLs and other examples, like, for instance, what you're going to see in the lecture that I gave about low-code application domain environments. In that case, on purpose, I didn't take anything that we have created. I just took, normal commercial tools. They don't have any of these mechanisms behind, okay? So they are basically nice drawings, okay, that can be transformed to code in a more or less hand-coded way, but there is nothing like this kind of analysis capabilities that we have in the Synco environment, and of course that we inherit, so to say, to the Synco products, like Dime and the ADDlib, okay? So once we have arrived there, okay, we can do the same game and basically have an ADD compiler that takes this graphical while DSL and transforms it actually into ADDs, which are the same ADDs that you are constructing by hand, okay, in the ADDlib example, okay. When you have that, like you're going to do in your exercise, there is an ADD, for instance, to JavaScript generator, okay. That one is then a model-to-model transformer now to a model that happens to be source code, legal source code in a programming language, but it is still a model if you really want to see it like that. So after 3 levels of compilation, you come actually to the code that you can run, okay, in the game engine of Dime, okay, when you can have your strategies playing really against another strategy or against a human user, okay? So there you can execute the standard runtime. So the total from Dime to code actually is quite a lot of transformation and a lot of mathematics inside, okay? So you start with Dime, you use a lot of Synco in different languages, and in order to do also a meta transformation, okay? Then you land from Dime in the adlib, and from the adlib you can come to the Java code, okay? So that's what I wanted to show. So any questions? So I hope that this explained a little bit how things hang together. So for the moment, it is not yet implemented in this way because we are still working on this Gsos Transformer, okay, which is a general language-to-language transformer for programming languages, okay, because sometimes you want to really translate a piece of Python into a piece of Java because it has to run as Java, and you want to make sure actually that it is exactly the same behavior, not something similar, but maybe yes or no, and that you have to test until you drop, okay? So this is actually a useful trick for this, and it is basically showcasing the power in this small example, okay, the power of having models and meta models and working with transformers, okay? Okay, so I think that I took more than the 10 minutes, but this is actually what I wanted to explain, okay? We will upload this part as well and the slides so that you can refer to them still later, okay? So this is extra. I'm not going to have a test on this, but just in order to explain a little bit what is the combination, so to say, at which level, so to say, are all the tools that we are using, okay? Okay, so were there any other questions in the meantime?